continuing, we are then, once we have it in this form where we've separated the variables, we are going to anti-differentiate. So we have h of y equals the integral dy over g of y, and f of x equals the integral of f of x dx. Okay? And so what you're going to have end up here is that h of y equals f of x plus c. And you have here an implicit equation of y, like we had where we had ln absolute value of y. Then we need to make it explicit. We take h inverse. And in this case, if you end up with just a y, that was about as simple as it could get. You have y equals h inverse of f of x plus c. And remembering logarithms and exponentiating are our inverse functions. Okay. So let's see. So example 2. Let's try another differential equations that we're going to solve by separating variables. Okay. We are going to take a look at a function where find a function where the slope of the tangent line is twice the slope of the ray from the origin. Okay, so what does that mean? We've got over here, we've got our x and our y, and we've got a point here. So we want the slope, this is the ray from the origin, that's the slope, and we want the tangent line at that point to be twice that. Okay, so this is slope m, and this would be slope 2m. Okay, so what we want is dy dx, we want our slope to be double the slope of m. But the slope of m, as we can see here, we just have m equals y over x, because that's the y distance over the x distance. So dy dx is 2 times y over x. Okay, notice that this here is undefined when x equals 0, because we can't have a slope there. So our solutions are going to be something where it will be undefined when x equals 0. Okay, so let's separate our variables. So we get the x's on one side, so we have dy over y equals 2 integral of dx over x. Multiply both sides by dx, divide both sides by y. Okay, so we get ln absolute value of y equals 2 ln absolute value of x plus c. Okay, we're going to do e to the ln y equals 2, e to the 2 ln x plus c. So y equals e to the ln x squared, because remember we can use our logarithm power rule, times e to the c. And so y equals a, some constant, x squared, where a equals e to the c. Okay, and right now we are only looking at positive solutions. We would have to do it differently if we were looking at negative x values, because what it would mean to be double would be a bit different, and we'd also have to look at a negative a. So what that means is y equals ax squared. So let's check and make sure this actually fits our differential equation. So dy dx equals 2ax. So if we multiply dy dx equals 2a, we'll multiply both by x over x. We get 2ax squared over x. Notice that this was the same as how we originally defined y. So we get dy dx equals 2y over x. Works for all a greater than 0. And what this gives us is we have y equals ax, which means x squared, which means we have any parabola, gives us this family of parabolas that all have their vertex at 0, 0. And where a can be anything, so that scale factor can be anything. And this is an infinite family of solutions.